the carbon atom is having 4 hydrogen atom, you can replace one of the hydrogen with a halogen. Then we call it as what? Haloalkanes. You can see that only one halogen which we have substituted by replacing with the hydrogen, hence it is monohaloalkanes. If the halogen atoms are present on the adjacent carbon atom, then we say it is vicinal halide. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidyashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with the Unit 10, the haloalkanes and haloarenes. So, before going to discuss with this unit, let's see the weightage of this unit. So, from this unit, we can expect one 1-mark question and one 5-mark question from the part D and from part A, and totally we can expect 6 marks from this unit. And the question number will be goes like this. The question number 8 from the part A and the question number 32 in the part D, that is in the 5th main, we can expect the question from this unit, and totally from this unit we can expect the 6 marks. Okay. So, let's see what we are going to discuss in this session. In this session, we are going to understand what are haloalkanes and haloarenes, and we are going to understand the classifications of this haloalkanes and haloarenes, and mainly we are going to study about the classifications of monohalo compounds. In that, the compounds which are containing sp3 hybridized carbonate halogen bond and the compounds containing sp2 hybridized carbonate halogen bond, we are going to study in a monohalo compounds. Okay. In addition to that, we are also going to understand the classifications of dihaloalkanes. Okay. Let's see what are the haloalkanes and haloarenes. Okay. The replacement of hydrogen atom in the hydrocarbon, that is in the aliphatic, either in the aromatic, by the halogen atom results in the formation of alkyl halide, and it is termed as a haloalkanes or aryl halides. Okay. And generally, we represent this haloalkanes as a Rx. So, I can explain this by taking the example of methane. We know that in methane, there are 4 hydrogen atoms attached to the single carbon atom, right? So, this is H, H and H. In all the, you can see that the carbon atom is having 4 hydrogen atom. You can replace one of the hydrogen with a halogen. Then we call it as what? Haloalkanes. Okay. Then we call it as what? Haloalkanes. So, this is haloalkane because it is a aliphatic hydrocarbon where one of the hydrogen which has been replaced with what? Halogen, hence it is named as what? Haloalkane. Coming into the aryl groups, I will take the example of benzene ring. Okay. We know that in a benzene ring, there are 6 carbon atom followed by 6 hydrogen atom will be there. So, if any one of the hydrogen, if it is replaced with an halogen, then we say it is aryl, or you can say this is also as a haloarenes. What we can call, this is also known as haloarenes because in the aryl group, one of the hydrogen which has been replaced with a halogen to form what? Haloarenes. Similarly, in the aliphatic carbon chain or in the aliphatic hydrocarbon, any one of the hydrogen atom, if it is replaced with an halogen, we say it is haloalkanes. And if it is an aromatic hydrocarbon, if you replace one of the hydrogen by substituting with the halogen group, then we say it is haloarine. Then what role the halogen atom can be replaced or it can be substituted to the aliphatic hydrocarbons and aromatic hydrocarbon? They are fluorine, chlorine, bromine and iodine. These are belonging to the group 17 in the periodic table. So in the periodic table, the group 17 elements known as what? Halogen. In that, the fluorine, chlorine, bromine and iodine, they can be used to substitute the hydrogen in the aliphatic or aromatic chain to form a haloalkanes or haloarenes. And generally we represent it with what? Rx. Okay. This is the general introduction to what? Haloalkanes and haloarenes. Coming into the classification. Okay. The haloalkanes and haloarenes will be classified as follows based on the number of halogen atom which has been attached to the aliphatic hydrocarbon chain and aromatic hydrocarbon chain. We'll see if the number of halogen atom, if it is increased in that chain or in that benzene ring, what we can say with that name, we'll understand one by one. On the basis of what? Number of halogen atom which has been replaced with a hydrogen atom. Okay. They may be classified as mono, di and polyhalogen compounds depending on whether they contains one, two or more halogen atom in their structure, and it can be represented like this. Here I have an example of haloalkanes where you can see that this is a C2H5X and it can be written as C2H6, right? So one of the hydrogen which has been released and it can be written as what? C2H5X, and this is an what? Haloalkane, and you can see that only one halogen which we have substituted by replacing with the hydrogen, hence it is monohaloalkanes. Okay, and coming into the dihaloalkane, you can see that this is an example for C2H6 again. Okay, again I'll replace this and I replace the two hydrogen atom, thereby I'll substitute the two halogen atom, hence it is known as what? Dihaloalkane. Similarly, if you replace the three hydrogen atom, then we say what? Trihaloalkane. Similarly, we call it as monohaloarene, dihaloarene and trihaloarene, whether the number of halogen atom which has been attached to the benzene ring. As the number which is increases, the name which is also changed from mono, di and tri. If only one halogen atom has been replaced, we say it is monohaloarene. If two halogen atom has been replaced with hydrogen atom, we say it is dihaloarene. If the three halogen atom which has been replaced with hydrogen atom, we say it is trihaloarene. So this is a classification of haloalkenes and haloarenes based upon what? Number of halogen atom which has been present in the aliphatic chain or in the aromatic benzene ring. So based on the number of halogen atom, we say it is mono, di and tri, as well as with the polyhaloalkanes or polyhaloarenes. Next is, we are going to understand the detailed study of classification of what? Monohaloalkane. So already we have understood that monohaloalkanes are the compounds of aliphatic hydrocarbon where one of the hydrogen which has been substituted with what? Halogen. Then we say it is what? Monohaloalkanes, right? And this monohaloalkane which is further divided into two types, they are the compounds which are containing sp3 hybridized carbon-hydrogen bond, and we have one more type, that is the compounds which are containing sp2 hybridized carbon-hydrogen bond. Okay, and this compound containing sp3 hybridized carbon-hydrogen bond which is further classified into three types. They are alkyl halide, allylic halides and benzylic halides. What are the three types? First one is alkyl halide, allylic halides and benzylic halides. So we are going to discuss what are the alkyl halide, allylic halides and benzylic halides in detail in the next slide. Okay. Similarly, the compounds which are containing sp2 hybridized carbon and halogen bond, that is also further classified into two types. They are vinylic halides and aryl halides. Okay. So this is a general representation of classifications of monohaloalkanes. Okay. Monohaloalkane compounds. First we will see the compounds which are containing sp3 hybridized carbon halogen bonds. Okay. So first one is what? Alkyl halides. That is the first classification, which is also known as what? Haloalkane, and generally we represent it as Rx. Okay. In alkyl halide, the halogen atom which has been bounded to what? Alkyl group, and they form a homologous series, and it is represented as CnH2n plus 1 into X, where one of the hydrogen which has been replaced with an halogen, and thereby we can change the general representation of alkane, that is CnH2n plus 2 will be there, but here we have changed to CnH2n plus 1 into X. Okay. And they are further classified into primary, secondary and tertiary according to the nature of carbon to which halogen atom which has been attached. You can understand by looking at this diagram. This is an example of alkyl halide, where you can see that we have a bond between carbon with the halogen, where this carbon atom which is undergoing what? sp3 hybridization. Okay. And you can further classify this alkyl halide into three types. They are primary, secondary and tertiary alkyl halide. First I'll go with the primary alkyl halide, where you can see that the carbon is and hydrogen, carbon and halogen bond, you can see that, and this carbon atom is undergoing sp3 hybridization, and you can see that there is a one alkyl group which is directly attached to the carbon chain, hence it is known as what? Primary alkyl halide, because already we have understood that primary alkyl halide, or generally you can say alkyl halides, have a general representation of Rx. If number of alkyl groups are increased, we say it is primary, secondary and tertiary. We'll see with the secondary now. You can see that there is a carbon and halogen bond will be there, where this sp3 hybridized carbon atom consists of two alkyl group, hence it is known as what? Secondary alkyl halide. Similarly, tertiary, you can see that there is a carbon and halogen bond will be there, but the carbon atom which is surrounded by three alkyl group, hence it is tertiary alkyl halide. So remember, alkyl halides are those in which the carbon atom is undergoing sp3 hybridized and it always bonded to one of the halogen atom, thereby the alkyl group can be increased or decreased. If it is increased, we say it is from the primary, secondary to tertiary. Okay. Next we have allylic halide. First we will understand what is a allylic halide, how we can represent it. Okay. These are the compounds in which halogen atom is bonded to the sp3 hybridized carbon atom next to the carbon-carbon double bond. Hence such carbon which is known as what? Allylic carbon atom. Here you can see that this is a carbon atom where one of the hydrogen which has been replaced with an halogen, thereby it forms what? X bond, that is carbon halogen bond, and this carbon atom which is sp3 hybridized and it is always present next to the double bond. Such carbon atom which is known as what? Allylic carbon atom. They are known as what? Allylic carbon atom. Okay, you can see that there is a double bond to which the carbon atom which has been attached and it has been replaced with one hydrogen with a halogen. We have one more example where you can see that this is a first carbon atom, okay. This is the first carbon atom, one of the hydrogen which has been replaced with an halogen, and this carbon atom you can see that which is directly attached to the second carbon atom where it is having a double bond, right? So such carbon atoms are known as what? Allylic carbon atom, and such halides are known as what? Allylic halides. Okay, we'll see with the one more type, that is benzylic halides. These are the compounds in which halogen atoms are bonded to the sp3 hybridized carbon atom next to the aromatic ring. So where exactly it has been attached? It is always attached to the carbon atom which is directly attached to the benzene ring. You can see that here we have a carbon which is sp3 hybridized and it forms a carbon halogen bond, where you can see that this carbon atom is directly attached to the benzene ring, thereby it forms what? Benzylic halides. Thereby it forms what? Benzylic halide. Hence such carbon atom is known as what? Benzylic carbon. They are known as what? Benzylic carbon. So you can see with one more example, this is a carbon atom. I can rewrite this structure also like this. Okay, this is a carbon atom. You can see that which is having the carbon and halogen bond, and this carbon atom which is sp3 hybridized, and you can see that it is directly attached to the benzene ring. Such carbon atoms are known as what? Benzylic carbon atom, and such compounds are known as what? Benzylic halides. Okay. Next we have the compounds which are containing sp2 hybridized carbon halogen bond. In that we have only two types, that is vinylic halides and arylic halides. First we will see what are vinylic halides. Okay. These are the compounds in which halogen atoms are always attached to the sp2 hybridized carbon atom of carbon-carbon double bond. You can see that this is a second carbon atom, or else if you take this as a first carbon atom, no problem. Okay. So this is a carbon atom where it forms a bond with the halogen, and this carbon atom which is sp2 hybridized, and you can see that this halogen atom which is always attached to the carbon atom where it forms a double bond with other carbon atom. We have one more example. You can see that this is a halogen where it has been attached to the carbon atom which is forming a double bond, and this carbon atom which is undergoing sp2 hybridization. Such compounds are known as what? Vinylic halides, which is known as what? Vinylic halides. Next we have aryl halides. Okay, these are the compounds in which halogen atoms are bonded to the sp2 hybridized carbon atom of the aromatic ring. So you can see that this is an halogen group which has been attached to the carbon atom, where this carbon atom itself is one of the member of the benzene ring. Such compounds are known as what? Arylic halide, where this carbon atom which is undergoing sp2 hybridization. We have one more example. You can see that again this is a carbon atom where it forms a carbon and halogen bond, and this carbon atom which is undergoing sp2 hybridization, and thereby this carbon atom which is itself will be the member of the aromatic benzene ring. Hence it is known as what? Aryl halides. These are the classifications of monohaloalkanes and its type. Next we have the classifications of dihaloalkanes. This dihaloalkanes are having the same type of halogen atoms which has been further classified into two types. So when we say it is dihaloalkane, only when the two same halogen group which has been attached to the aromatic benzene ring or to the aliphatic benzene ring. Since we are discussing the dihaloalkanes, we need to just look at with the two halogen atom which has been directly attached to the aliphatic carbon chain, which has been further divided into two types, that is geminal halide and vicinal halide. First we will see what is the geminal and vicinal halides. If the halogen atoms are present on the same carbon atom, then we say it is geminal halide. If the halogen atoms are present on the adjacent carbon atom, then we say it is vicinal halide. You can see that this is a two halogen atom. Since it is in a dihaloalkanes, it is a two halogen atom which has been directly attached to the same carbon atom, right? Such halogens are known as what? Geminal halides, or it is known as what? Gem dihalides. You can see that we have a vicinal dihalide where the two same halogen atoms which has been attached to the different carbon atom, hence it is known as what? Vicinal dihalides or vicinal halide. This is how, even though it is a dihaloalkanes, if the halogen atoms are attached to the same carbon atom, we say it is a geminal halide. If it is attached to the different halogen group or different carbon atom, we say it is vicinal halides. Okay, this is how we can name the dihaloalkanes and its type. In the next session, we are going to discuss in detail about the nomenclatures of this haloalkanes and haloarenes. So, hope you are understood with this session. We'll meet you with the next session. Till that, take care, be safe. Thank you.